Now this is R.D. Sharma solution. We are taking chapter 19, which is indefinite integrals. Now this exercise may be different in your edition. I am taking 19.27. Whole idea is the logic which I am going to tell later. Now in this exercise there are two formulas which we will be using all through. First is e raise ax sin bx dx. The second one is e raise ax cos bx dx. Now let me write it so that it gets embedded into your mind. And there are certain analogy also, similarity also that you will find here while I am writing. So integration of e raise ax sin bx and integration of e raise ax cos bx. The similarity first is that first term remains the same. That is e raise ax divided by a square plus b square in both the terms. So e raise ax a square plus b square, just write it here. They both will be found in both of the equations. Now inside this, of course, we are dealing with indefinite integrals, so we ought to have a constant of integration. Now when we have e raise ax sin bx, just take a and sin bx. So write this a and this sin bx. So a sin bx. In the same way, we have a cos bx here. Because it is e raise ax cos bx, take an a and then cos bx. In sin, there will be a negative sign. In cos, it will be a positive sign. Now you just change sin to cos, that is sin bx is there, so make it cos bx. And in the second equation, cos bx will be sin bx. But it will be followed by b, means in both these, followed by a b in front and b along with x. So b cos bx, b sin bx, b cos bx, b sin bx. Alright, I tried to make this fed into your mind. But it's better that when we give a proof, then the whole intricacy will be revealed to you. The e raise ax cos bx is actually your question number 1. So we are going to solve this, but in the questions. For that, for the beginning, e raise ax sin bx, I am going to give you the proof. So we are dealing with e raise ax sin bx. Let's call it as an I, because this is our original integration. And please remember, this is going to be coming again, means we will be revisiting again. Now this e raise ax sin bx, whichever you want, you can take as the first function and second function, because the result is going to be the same. Let's take e raise ax as the first function and sin bx as the second function. So the formula of uv dx is known to you. We start with a u, then integrate v, then minus. Then when we differentiate the first function, that is d by dx of u is done, then the integration of this v dx will be done. So integration of v dx. And once this is done, then we have to multiply them, and again a final integration will be done. So we are going to apply this formula here. You can take uv either of them. It's up to you. I am taking e raise ax as the first function. But when I am going to tell you e raise ax cos bx, then you'll see I will just switch the first function and second function. So e raise ax comes outside. Sin bx is integrated. Minus. Then differentiation of the first function, which is e raise ax. Then the integration of sin bx dx. Once this is done, then we will integrate all the content on the right hand side. So e raise ax sin bx is minus cos bx, and then bx will be differentiated, it will come as b, and that will be put in the denominator, minus. Now d by dx of e raise ax, again e raise ax will come. Then differentiation for ax will also be done, so a will also come. Sin bx dx we have already done, it's negative cos bx by b. So just write this cos bx by b. And negative, you can just make this negative in front as positive. Negative becomes positive. So what we will do here, we will take this a and b, which are actually the constants, in front. Means it will be prior to integration sign. And this e raise x cos bx, we will call it as some integral, say I1. So I am doing it separately just to reduce the clumsiness. So e raise ax cos bx, we are integrating it. See, this is the second function I am talking about, which we will be dealing in the question number 1. But here, e raise x cos bx, we'll apply the formula now. So it's e raise ax, again same thing, cos bx minus integration of, now first the differentiation of e raise ax will be done, and then the integration of cos bx, and this whole will be again integrated with respect to dx. So e raise ax will come, cos bx is simply sin bx, and then bx will be differentiated, b will come, it will go in the denominator, minus integration d by dx of e raise ax will be e raise ax only, then a will also come after the differentiation of ax. Cos bx we have already done, it is sin bx by b. Now we have to integrate this again, the second part. Now what do you see here? You will say that this will be never ending process. You will integrate again, cos will come, e raise ax, cos bx will come. Again you have to do this will be a round robin thing. No, you will just see, if you take this, let me write e raise x sin bx divided by b. But the second term, if you take a by b outside the integral, what will remain inside? E raise ax sin bx. But to our utter surprise, this is already what we have started. Means this is what the integral we have started with. So you don't have to integrate it again and again. You just have to write I in front of that. So e raise ax sin bx divided by b minus a by b, and this particular thing is I only. Alright. So this I1 I told you. So we started with this one, I1. And we came to this one, that is I1 is equal to this expression which you see on the right. So let's proceed the initial one, negative e raise ax cos bx by b plus a by b. Now I am bringing this in, which I just called as I1 at my discretion. So e raise ax sin bx by b minus a by b, I is already there. So let me write this again, e raise ax cos bx divided by b. Now multiplying a by b inside. So this will be a e raise ax sin bx, and this b and b will become b square. Now the second term will be multiplied, a by b into a by b will be a square b square, I, and I remains here on the left. Now I am taking this, the rightmost thing, to the left hand side. So when I take this on the left hand side, it will be I plus a square by b square into I plus a square by b square into I. So you can take I common, and this will be 1 plus a square by b square. And this will give you what? LCM take, just multiply this b square plus a square by b square. So a square plus b square by b square into I will come. So the left hand side I have done it here. I have taken this on the left hand side. So let me write the final result here of the left hand side. A square plus b square by b square into I. And on the right, I am just swapping these two terms, because e raise ax is already common. So you can take e raise ax outside. Now I am swapping these two terms, sin bx first and negative cos bx outside, just to show that this matches to what I have told you earlier. Okay. So e raise ax we have taken common. Sin bx I am writing first along with an a. So a sin bx by b square is already there. Now I am writing the first term which contains a negative. So you have a negative cos bx divided by b. Now why I did this? Because we can take the LCM here. When we take the LCM will be b square. So I am showing it to you here because it's getting very clumsy. So I am going to show you here. B square, when you take LCM, b square is also already there, so you don't have to do anything. You can just write a sin bx. And since b square is not there, only b is there, so you have to multiply b to make it as b square. So b cos bx will come. So the final version is e raise ax, or not final but penultimate. So a sin bx minus b cos bx divided by b square. This I have just done. And you have on the right a square plus b square by b square into I. So this b square get cancelled. A square plus b square you can bring it on the right. A square b square you can bring it here. So this is what I am going to tell you or show you, that this is the final result. E raise x is already there. Denominator is a square plus b square. Now you have a sin bx minus b cos bx. And now you can add a constant of integration if you want, because indefinite integrals without a constant of integration will not worth anything. So I is this one. So I hope you got the idea. Now the second one, which is actually the first question. This is also a formula which will be used immensely in this exercise. So e raise ax cos bx is equal to what you see on the right, and I am going to prove it just now. So we have already proved e raise ax sin bx. Now we are dealing with e raise ax cos bx. So you are always told that I late you can follow. Okay, inverse, log, algebraic, trigonometry and exponential. So you can follow this, or you can take any of these as the first function and second function, because in the previous discussion just now, I have taken otherwise. But here you can take in a different way, because this particular integral doesn't follow this I late. Means either of the function can be taken as the first function and second function. Actually, I have tried out, that's why I am telling you. You will see it just now also. And you will see the difference between e raise ax sin bx and e raise ax cos bx. The previous one I took different first and second function. Here I am taking different first function and second function. So I is actually e raise ax cos bx, which we are integrating. and I'm writing it again just to show you that this is going to come again. This will be regenerated while we are actually solving the question. Now let's apply the formula. This I will be equal to, so integration of uv dx, I told you already in the previous one, so I'm going to just apply the formula here. So this is cos bx as the first function, integration of e raise ax, and then the differentiation of the cos bx first function, and then integration of e raise ax, and then with the dx. So we have cos bx, integration of e raise ax will be e raise ax, and then the differentiation of ax will give you a, and that will be kept in the denominator. So you have a in the denominator, minus. Now cos bx will be what? It will be negative sin bx. Remember, you are differentiating here. So minus minus, I'm making it plus here itself. So minus sin bx, cos bx will be negative sin bx, and then bx will also be differentiated. That will give you b. And what about integration of ax? It will be e raise ax by a. So we need to integrate it again. Let me add b also. So this has to be integrated again because it is inside an integral sign. We have e raise ax sin bx. I have taken b by a outside. So let me just compete by writing this e raise ax divided by a, and this is cos bx, I equal to this one. Now let me call this as I1 because I am going to do it separately just to increase the understanding. E raise ax sin bx on the right, I have taken it as I1 at my disposal. So again, you can take any of this as the first function, any of this as the second function. You don't need to follow I late. So I'm taking sin bx as the first function and e raise ax as the second function. So let's start with sin bx now. This is sin bx, integration of e raise x minus integration, then the differentiation of sin bx will give you cos bx, and then since differentiation has been done, b will also come. Integration of e raise x also. So we have sin bx, this will be e raise ax by a minus this differentiation of cos bx has already sin bx has already been done, so we have a b cos bx. So there will be b cos bx. I have left it, just assume that it is there. E raise ax will be e raise x by a. So let me write b also and cos bx also. So cos bx here. Now to our again a surprise, you'll see that from where we have started, we have again come back to the same juncture. That is the first term I am writing like that. But here if you take b by a outside, the inside will be e raise ax cos bx. And what is this? I told you that it is going to be regenerated. It will come again. So this is I only. So let me substitute this as I only. That is e raise ax sin bx divided by a minus b by a. And this integration of e raise ax cos bx will be I. And there is a b by a also. So let's multiply b by a here only just to make it clear and not very clumsy. So b, I'm multiplying now. So b e raise ax sin bx is the numerator, a into a is the denominator, a square. Now again b by a into b by a will be b square by a square with our I. Now I am taking this all and putting it in the original equation. So e raise ax cos bx by a will remain like that, plus b into e raise ax sin bx by a square. I'm just taking this and putting it here. Nothing, no change I'm making it here. Minus b square by a square I. Now this rightmost thing, I am just taking or transferring it to the left hand side. So this will form I plus b square by a square into I equals to what? I 1 plus b square by a square if you take I common. So this will be a square plus b square by a square into I. So left hand side will be now a square plus b square by a square into I. And on the right hand side, e raise ax, let's take common. What will remain inside? Cos bx plus b sin bx. Here it will be a and here it will be a square. Now let's take the LCM. When you take the LCM, it will be a square. So since this already have a square in the denominator, you can just write b sin bx. Here we have only a in the denominator, so in order to make it a square, you have to multiply it with a cos bx. Okay, e raise ax remains here. Now a square plus b square by a square. First thing is you can just cancel this a square and s square in the denominator, and you can bring this a square plus b square on the right. So this integration I will be e raise ax, in the denominator it will be a square plus b square, and followed by a cos bx plus b sin bx. And now you can add a constant of integration, and this is the actually the proof also and solution of the first question as well. This is from where we started, okay? So this is the proof of e raise ax and e raise x, cos x and cos bx and sin bx. Now just need to see it cleaner, and I want you to do it again. I request you to follow this, because all the other questions which are coming up, if you don't understand this e raise ax, cos bx and sin bx integration, it will be very difficult for you to understand the other question. So give it some time. I have seen some people have said that this c doesn't matter, and they just said that it can be equal to 0. But I am going to tell you the detail of this in the later part. Till then, thank you so much. Have a good one.